Good day, my name is Chigozie Ifeanyichukwu. I'm a Nigerian. I'm a student of AIT and my program is Electrical and Electronic Engineering. My index number is ENG13B00250Y. And I'm here to make a project presentation on two engineers who inspired me in the field of engineering. Now, in this project, I'll be talking on these two people, what made them choose this career path, at what point in time did they decide to face this career, the obstacles they had to face in the career path, and what made them successful, and finally, I'll be talking on their advices for beginners in the career like me. Now, first of all, I'll be talking on Sir John Ambrose Fleming. And secondly, I'll be talking on Professor Alan V. Hoffney. Now, these men are great men who have took extraordinary steps to produce extraordinary things, and these things have made life worth living. They've made things easy. They helped in the advancement of technology. Now, have you ever asked yourself how it's possible for radios to transmit through waves? How we are able to communicate through long distances, how communication is possible? Have you ever imagined how digital computer came in existence? Have you ever imagined how we can convert digital analog signals to digital signals, discrete and continuous systems? Have you ever imagined how radios could be listened from different locations, through waves? These are all because of the inventions of these great men. Now, I'll be talking on Professor Alan V. Hoffney, secondly, and firstly, let me talk about John Ambrose Fleming. Now, John Ambrose Fleming is also known as the father of modern electronics. He was born 29th of November 1849. He was an English engineer and physicist. He invented the first harmonic valve or vacuum, and this diode was later called the kinetron. Now, he's also famous for the left-hand rule of electric motors, also called the Fleming's left-hand rule. Now, this rule is a rule in which transformers, generators, electric motors, solenoids, they work under this rule. Now, this rule is called the left-hand rule because all transformers, generators, motors, they all turn to the left. They walk through the left-hand side, and with it turning to the left, they generate power or electric energy or magnetic energy. Now, all this is because of the invention of this great man. Now, I'm going to talk of his early life and his educational background. Now, even as a boy, he has decided to choose this career path. Now, he wanted to become an engineer as a boy. At the age of 11, he had his own workshop where he built model boats and engines. He even built his own camera and started a lifelong interest in photography. It's so amazing. You know, this John Ambrose Fleming, he inspired me a lot. And talking about the challenges and obstacles he had, training to become an engineer was beyond his family's financial resources, but he researched and reached his goal via a path that alternated education with paid employment. Now, since his parents could not afford him going to college and being an engineer, because the cost of studying engineering was high, he had to take an extraordinary step. He has to take a bold step to working. He started working and going to school. You know, it's not really easy combining the stress at work and schooling, and still though he also made good grades. And you know, this is so wonderful. It's something that inspires most students. Something that inspires me a lot. And talking about some of his activities and achievements. Now, the DeForest device was refined by him and Edwin Armstrong into the first electronic amplifier. Now, this first electronic amplifier is a tube called the triode. Now, the triode was vital in the creation of long-distance telephone and radio communications, radars, and early electronic digital computers. Now, with this triode, we were able to make communicate through long distances, radios, signals, radars. It was all possible through this triode, and it was because it resulted through the invention and research made by John Ambrose Fleming. Now, his encouragement and advice for beginners in the field to inspire them are so numerous. He has talked a lot. His biography, he talked in an interview on CNN recently. He talked where Professor Alan V. Hoffman was interviewed on CNN on his career path, and he talked a lot, and he spoke a lot on how he worked hard, and he encouraged us beginners in the field to keep it up. And John Ambrose Fleming, he's a devoted Christian, and he preached on one occasion at St. Martin in London, where he spoke and advised the youths on the way to succeed. He bequeathed much of his estates to Christian charities, especially those who help the poor. Now, John Fleming, he's so generous that he had to give some of his properties to charities. He helped the poor, and he introduced many youths into engineering. He took many to school. He sent them to school to study, and because of his great inventions and achievements, many of them were inspired to go to the field of engineering, and this is helping the global economy today, because we have engineers are working day and night to produce new things, to work on existing technologies. And Professor John Ambrose Fleming, he has received a lot of awards, and some of the awards are the Hughes Medal, which he received in 1910, the Albert Award, which he received in 1921, the Faraday Medal, which he received in 1928, the Dudell Medal, which he received in 1930, the IRE Medal of Honor in 1933, the Franklin Medal in 1935, and the Fellow of Royal Society. Now, these are many more of the awards which he received, and these inspired me so much, and I am eager, and I want to study, and I want to achieve and make my own inventions. And now, secondly, I'll be talking on Professor Alan V. Hoffman. Now, Professor Alan V. Hoffman, he received the SB and SM degrees simultaneously in 1961, and the SD degree in 1964, all in electrical engineering. His 2 degrees were on electrical engineering, and he studied at Massachusetts Institute of Technology, MIT. Now, after studying MIT, he graduated with good grades and first class. He was a first class student in his 2 degrees, and MIT, he decided to join MIT, to work for MIT. Now, he joined the faculty at MIT, where he is currently the 4th professor of engineering and a McVicker faculty fellow. Now, Professor Alan V. Hoffman chose this career path while he was still young. He was interested in radio signals, and he always wondered how he could improve on signals and systems, and this has been his drive. And most of the challenges he had to face in this career path was that sometimes signals is difficult to tell. Signals is difficult in the transformation of signals. Is not that easy, and because of these challenges he faced a lot of challenge, because transforming signals was not that easy. It's not something you can just do. So he had to come up with devices. He had to come up with circuit analysis that he can use to simplify these circuits, and this is a way he tackled his obstacle. And through this signals processing and systems are easily done today. Now, so he has received so many outstanding awards because he taught. He's a good teacher. He's a professor. He teaches beginners and he teaches young engineers in the field, and this serves as an encouragement and an inspiration to them also. Now, he has received so many awards for his outstanding research in signals and systems. He received the awards. Some of the awards he received include the IEEE Senator Award in 1984. He received the IEEE Education Medal in 1988. He received the IEEE Third Millennium Medal in 2000, and also the IEEE Jack S. Kilby Signal Processing Medal in 2007. He also received the Societal Award and the Technical Achievement Award. Now, he also received an award called the Senior Award of IEEE Society of Acoustics, and he also received another award on speech and signals processing. Now, these awards are so numerous, man, and MIT awarded him for excellence in teaching, including the Boss Awards and Everett Moore Baker Awards. Now, these great men have done so much, because of this, communication is made easy. We can communicate. We can stay here in Ghana and call America. We can send messages. We can send emails. We can send text with our phones. These are all signals. When you send text, you're transforming an analog to a discrete signals through wave. And through these signals, and this is what all these are possible because of these great men who has made this invention, who took these extraordinary steps to make greatness. Now, I'm so much inspired by these men, and choosing this career path is not something I'm going to regret. And I know I'm going to make success, and I'm going to be successful in this field I've chosen. Thank you for listening. Thank you so much. Have a nice day. It's your boy Chigozie Alex Ifeanyichukwu. Thank you.